Hello everyone, I'm Miraj Sharir and I'm currently the group leader of our team. Today we are here for the second video report. The main purpose of our project is basically to make an autonomous robot which can track the, the motion of a moving object at varying speeds and angles. We have already made significant progress and we recently finished a customer design discovery goal. From that, we got positive feedback from the customers, and we talked to a bunch of engineering students and a few facilities manager and manufacturing engineer, and they liked the idea of our project and they believe in the future potential of our project, and they also gave us few ideas where it can be used, such as autonomous baby stroller which can follow the parents around, or a moving pallet which can be used in a manufacturing or a facilities warehouse to move heavy objects. Yeah. So I'd like to talk about the future roles of our group that we have decided. So here on my right, Soham would be in charge of the programming and software and coding. Jared will also assist him and will be in charge of the programming and coding for our project. And Moises will be in charge of the hardware part. So yeah.
Okay, so far this semester we developed a finalized design for what we're going to call the control unit of the circuit. So what the control unit is going to be is the Raspberry Pi computer and the motor driver and the associated wires and connections with that are going to be placed onto our follower RC car. So the basic flow of the circuit that we've decided upon is that the voltage outputs from the Raspberry Pi computer are going to go through the motor driver, and from the motor driver, they're going to go to the two motors that are on our car. So the two motors are the DC motor that is used to control the speed of the car, and then the other motor is the servo motor that controls the direction of the car. So then, because for these two different motors, we're going to have two different types of signals from the Raspberry Pi through the motor driver, which is going to be digital outputs that are either on or off. That'll control the speed that the different motors are turning. And then we're also going to have PWM outputs, which is kind of an artificial analog output. And that'll be to control the power to the motors and the speed of the motors. So then from there, Soham is going to talk about what we've accomplished so far for the technical aspects of the project, and then kind of what we will be accomplishing for the technical stuff.
Thanks. Since the last video, we tested the motors of the RC car we will be using on different outputs, voltages ranging from 1 volt to 9.6 volts. We found there were some issues with the servo motors which are used for the direction of the RC autonomous car. That's mainly because of the torque at the lower voltages are not sufficient to change the direction of the car, and our hardware designing team has taken that into consideration, and we will be modifying our chassis. We also made a Python program to get the outputs, digital and PWM signals on the pins of the Raspberry Pi. And in the future, we will be merging all of it to actually accomplish our task. Now, Moses will talk about the hardware aspects of our program.
All right, so hardware-wise, we basically have all of our design done, so I'm just in charge of basically assembling our whole prototype. We have all our components bought and gathered. I would just need to render and 3D print a mount for the Raspberry Pi to sit onto the RC car chassis, and then I'll also be helping Soham, like you mentioned, figuring out how we can control that servo motor at lower voltages because of the weight distribution of it. There's too much stuff going on in the front. So yeah, well, and also soldering the Raspberry Pi pins, their input and output pins, and then that's basically all there is to do for hardware design and building. So this way, by the start of next semester, we can begin our testing and troubleshooting phase, which is where we wanted to be by the end of the semester.
Thank you.